We have to be careful about memory management as, remember, we are literally the ones creating the pointer setup for the array or matrix. So what I'm going to show you is a couple of oopses that happen. All of them end up being memory leaks, and you know that's a bad thing. You're actually going to explore this again when you get into data structures, and especially if it's C++ or something like that, where again, you're using heap data to store a lot of things with linked lists, vectors, again, things you'll do in data structures. So I'm going to have a couple different scenarios where we have an oops and then how to fix that. So in our different scenarios here, where you see a 3 and 7, they're going to be replaced by blocks here. I'm going to show you 7 blocks or 3 blocks, but we're going to leave it. Just think of it that way. It's not literally the data 3 and 7, so I want to make sure that's clear. But anyway, so in our reallocation issue that we could have is that we have our first normal array set to 3 blocks of integers. Nothing crazy with that. But then after that, we went ahead and set k, the same variable, which is a pointer, now to another integer array that now has 7 blocks in it. Well, the bad part is we never got rid of the first set of blocks, and then we can reuse it afterwards. So what it should have happened is that, the highlight will go over here in a second. Notice the only thing in between that really should have happened is we should have deleted the first version of k and then reallocated for the second version. That's the only fix. Now, by the way, yes, I've seen both. I put that in there on purpose. The square braces can be used on creating a length of it or creating a dynamic array, or the parentheses. Both of them happen to work, but I just wanted to show you that. But other than that, the real focus is that in between, I really need to delete k, so we delete this portion here, and then if we created a new one that had 7 blocks, fine, great. The other one's already taken care of. Here's another version that could happen, and that's an incorrect return. What's happening here in this overall setup is we have a function that's creating an array of 15, but notice what's returning just the element, the first element in the array. Remember how we did that with Terry? And matter of fact, it's on the first page of this notes and in these stack array notes. Here it ended up actually only returning 1 value. Now, how do I know that exactly? Because look at the function. Only returns an integer. So 1 value is going to be returned out of here, but notice it had 15 that was already set up. So when we set up the 15 and had everything ready to go here, I only returned 1 value from it. Well, that's a memory leak too, because notice I didn't delete anything or any of that nature. They're probably looking for something more, well, specialized when it came to that. Now, I think the original author was supposed to try to get, here's our new array that I talked about, we've talked about that before. They were trying to have this W get a new array. We can pass a new array back from a function, which I'm going to show you here in a moment, but this is messed up. Let's just put it that way. Okay? As soon as I see any type of new int or new, I should see a delete here. Matter of fact, there isn't even a delete for the k here on that one. So I would have had 2 memory leaks in this one. How do I do this? I talked about returning an array. Notice int star. Okay? Here, I create the array, and here I return it. I don't need to delete it yet because I'm going to accept it here. Now, the funny part is so this is the array, gets pointed to a new variable of a, which is just fine. Nothing wrong with that. But the bad part is I didn't delete it afterwards. There should be a deletion after I use it. And again, that would be deeper in the code just before the return 0. But this is how we would be able to return a value or return an actual array, a dynamic array in C++. Here's the last one that I've actually mentioned before, and that was a dangling pointer, is that frankly, even when we do the deletes, so everything is set to go, the memory's returned, just to be safe, we should have our pointer set to something called null pointer, which you've probably seen before, but just to make sure that it's still not dangling out in the wind there and that it's still actually pointing to some legit memory, because again, we reuse it, so that memory still may contain the original data. We want to make sure that we set it to a null pointer, which as you know is a reserved word in C++, so that it is capped off, it is safe, it can't access any legitimate data. So notice that all of these end up, as soon as I'm done, right after the delete, I'm going to set it to a null pointer. As soon as I'm done, right after the delete, set it to a null pointer. Just to be safe, to make sure it's not accessing anything else. And that's our dangling pointer issue that we could have in memory with dynamic arrays.